All right, so this density problem is a little bit more involved. We have a rectangular cube with mass of 2.60 pounds, with one side of the cube being 5.4 inches. Two lines is inches, and then one single quote would be feet. Right. So we have a mass, and they want us to come up with a density. So I know I need to get a volume. Well, they didn't give me a volume, but they gave me one side and they told me it was a cube. So since I know one side of the cube is 5.4 inches, I know that all sides of the cube are going to be, again, 5.4 inches. But they want the density in pounds per foot cubed, or square, or cubic feet, whichever way you want to say it. And that does not mean that I calculate the volume from the inches. I always convert first. Okay, so I am going to say 5.4 inches, and I need to change that into feet. From my conversion sheet, I know that 12 inches is 1 foot. So what I'm converting to is on the top. What I know is on the bottom. So my inches are going to cancel. 5.4 divided by 12 gives me 0.45 feet, 2 sig figs. 2 sig figs. So that same thing that we're using before, we're just not using metric units, just to give you a little bit of practice with the English units. That is one side. So I know volume is side cubed because it's a cube. 5.4 cubed centimeters cubed. Because both things are, these aren't centimeters. Let me rewrite all that. 0.45 feet. And I have to cube everything. So I'm cubing the number and the units. Feet times feet is feet cubed, or cubic feet. 0.45 times 0.45 times 0.45 is going to be 0.091, 2 sig figs. So now I have a volume and I have a mass. So now I can go back to my regular density triangle. Okay, I'm finding density, so I cross that out and I'm left with M over V. So density equals M over V. Mass, 2.60 pounds over volume, 0.091 feet cubed. 2.60 divided by 0.091 gives me 28.571 pounds per feet cubed. But wait, what do I need? 1, 2, 3 sig figs, 1, 2 sig figs. So my answer can only have 2 sig figs. So that 28 is going to round to 29 pounds per feet cubed. That is what I calculated from the lab with 2.6 pounds and 5.4 inches when I measured the side of the cube. But when the official people did it, they got their actual value, or the book value, or the accepted value, or the official value. You could use any of those numbers to be 26. So percent error is going to give me a different equation. Percent error is equal to accepted minus measured over accepted times 100%, and you can do the absolute value of those guys. Accepted value, that's the official value, 26. Measured value is what we did, 29. Over accepted value, again, 26 times 100%. And 26 minus 29 is -3, so I'm going to take the absolute value of that. So 3 over 26 is going to give me 0.1153. But now I have to multiply times 100%. So you're not actually going to type in the percent when you multiply. You're just going to type times 100. And we're going to keep the percent, kind of like how we keep the units. And that gives me 11.53% as my answer. And what did it say? Oh, 1 decimal place. So we're keeping the 1, 1, and 5, and the 3 tells us to round down. So 11.5% is going to be your answer. So our number from the lab was off by 10% from what the official number is. Does that make sense? Yeah, because 10% would be being off between 2.6 and 2.9, and we're off by 3, and it's off by a little bit more than that. So that's our physical double check that we're on the right track.